Very well. Mag 1C, Chapter 10, 10.1. We're going to talk about parametric equations, parametric curves. So suppose you have just a particle moving in two-dimensional space. You have x-axis. Well, of course, you have y-axis. This particle starts by moving along a curve like this. Okay, let me just move this here. Perfect. So this is your particle, and it's moving along this curve. So this is the location of your particle. This is the position of your particle. At this point, it is x sub 0, y sub 0. When it moves along the curve at this point, for example, it is x sub 1, y sub 1. At this point, for example, it is x sub 2, y sub 2. So it just gives the position of your particle. Here's a question. What if I want to time the movement of this particle? How can I add time or new variable like t to this particle? To add a new variable, like time, t, we define something that we call parametric equation. We use parametric equation. So let us write down the official definition of a parametric equation. We can define the position of a particle using two new functions that depends on t. So we are on page 1 of the notes. Definition of parametric curve. Let x and y as two variables are given as functions depending on a new variable like t, time. So suppose x is equal to f of t and your y is equal to g of t. So each of these points can be defined using two new functions. We're going to go over one example. You feel more comfortable about this. Then x and y as the position can be defined as f of t and g of t. So instead of using x and y, we can use just variable t, this new variable that x and y are dependent on. So this guy is a parametric curve. Parametric curve because you're using a new parameter t. So since these two x and y, these two variables are dependent on a new variable t, new parameter t, we call it a parametric curve. So let us go over one example to feel more comfortable about this new definition. We are still on page 1. Example. There you go. This example says graph the following parametric equation. So what do we have here? The first one says, very well, I'm going to write A here for you and B here. It says, suppose x is defined as cosine of t, and your y is defined as sine of t. And in this case, your t is ranging between 0 to 2 pi. So the parametric equations are given for part A. For part B, says, okay, now suppose you have a new parametric equations, which is A times cosine t, and your y is defined A times sine t, in the condition that t ranges between 0 to 2 pi. Well, okay, how do we graph these two? Let's think a little bit. This guy says I have x equals to cosine. This guy says y is equal to sine. And I know that, we know that sine squared of alpha plus cosine squared of alpha is always 1. Okay, this is very similar to this equation that we learned before, trig identity. So my x is cosine. Here I can write x as cosine raised to the second power plus my sine is y. So I can write y squared. This is equal to 1. X squared plus y squared is equal to 1. If you remember the equation of unit circle, we learned about unit circle in pre-calc. You know that x minus a squared plus y minus b squared equals to r squared is equation of a circle centered at A and B with radius r. We know that. So this guy is equation of a unit circle. A circle with center at the origin and radius for r equals to 1. We know that this parametric equation is nothing but a unit circle. Rotate once. This is my x-axis. This is my y-axis. My unit circle. So the angle, or t, ranges between 0 to 2 pi. Unit circle. So I got rid of variable t. So if you replace this guy by any other variable, instead of alpha, you can use theta, you can use t, you can use any variable you like. I got equation of a unit circle. So this parametric equation is nothing but a unit circle. So this is your conclusion. Parametric equations. X equals to cosine t, y equals to sine t, while t is between 0 to 2 pi is unit circle. This is your conclusion about this parametric equation. Very well, let us move on to the second example. X is equal to a cosine, y is equal to a sine. Okay. I have again cosine, I have again sine, and the coefficients are the same. I'm going to get back to the formula that I have, and now I'm going to square both of these. So what is x squared plus y squared? My x is a cosine t. So this is a times cosine t, everything raised to the second power, plus my y is now a sine t. So I'm going to raise a sine t to the second power. And I know that this side is equal to a squared cosine squared plus a squared sine squared. There you go. Here I can factor out a squared. So I get a squared parentheses cosine squared plus sine squared. Well, I already know that sine squared plus cosine squared is equal to 1. This is trig identity. So this is equal to a squared. So x squared plus y squared is equal to a squared. But what is this guy? This is a circle centered at the origin with radius equals to a. A circle with center at the origin and the radius equals to. And since t ranges between 0 to 2 pi, it just rotates once. So if you want to graph this function, this parametric equation, the graph is like this. X-axis, y-axis, and you have a circle. It's not a unit circle. The radius is now a, and it just rotates around once, counterclockwise. So t is between 0 to 2 pi, and the radius is a, so a minus a and minus a. This parametric equation is a circle centered at the origin with radius equals to a. So this is your conclusion. Parametric equations is a circle with center at the origin and radius equals to. Okay, we have a chat question. Any question, any confusion?
I have a question. So for parametric equations, you're basically like joining the two equations into one, correct?
So sometimes it's easy to get rid of variable t and get rid of this third variable. Some other times it's not that easy.
So my question is like at the end, you should be able to just instead of two graphs, correct?
It doesn't give you two graphs. If you plug in 0, so we're going to discuss that later. Another method to graph this is just plug in different values for your t and evaluate x and y. So it's going to be like this. I have t, I have x, I have y. So if t is equal to 0, my x and y is equal to 0. If t is equal to 1, my x is 1, my y is 1. So the first point on the graph of the function is 0 and 0. The second point is 1 and 1. If I plug in, for example, 2 as t is positive, then x is square root of 2, y is equal to 2, square root of 2, 2, and you have to plug in more points to understand the behavior of the position. So if you get rid of variable t, you can actually see the position function, which is y equals to x squared.
Thank you.
Sure. X and Y are both variables. You can say that. You can say that. It's just the position of the particle. If you want to get a sense of how it works, yes. Please take your time. If you have any question, feel free to ask your question. We have a chat question. Perfect. So t can be 0, t can be 1, t can be 2, t can be 3, anything. So if you set this equal to t, it means that you can form parametric equation of your line. That's how we form parametric equation of a line. This is a non-parametric equation, and you can set it equals to t and find a and b, then you can form parametric equations of a line. That's how we define it. Make sense for everyone? Yes. So when we're talking about parametric equations, it means that we are adding a new parameter, which in this case is t, your original equation. So your original equation has only x and y, just two variables. By adding a third variable later on in multivariable calculus, you see you can add 2 more variables, 3 more variables, and so on. One variable can be time, the other variable can be heat. So a position of a particle depends on time and, for example, the temperature. So we can add as many parameters or new variables as we want. Yes, they must be the same. Because in this case, you are connecting the position with the same time. You look at your watch and you watch your particle moving along one line. You don't use 2 different watches, it's just the same watch. So T stays the same. T must be the same. They are not different equations at different times. At the same time, you have X coordinate and Y coordinate of the position. So any position has X and Y.
I was wondering if you set the parameter, T equals to let's say 5, then you would result in a different equation as X equals 5T minus 2 and Y is 4T plus 1, right?
But eventually we get the same thing.
I was saying, okay. I will try it.
Eventually we get parallel lines. They're parallel to each other. Yes, that's how we define a line. So this is equation of a line passing through a point and parallel to a vector. That's how we define equation of a line in 2-dimensional space. That's the definition. So you get parallel lines, David.
Parallel, okay, thank you.
Sure. Any other question, any confusion? Okay. Let's move on to the next example. We are on page 3. Page 3. Okay. The question says, this is an example for you. It says sketch the graph of x equals to t squared minus 2t and y is equal to t plus 1. Perfect. So let me show you two different methods. The first method that you learned, first method, is to just get rid of your t. Try to write an equation without t. Okay, perfect. How do we do that? In the second equation, your y is equal to t plus 1. So my t can be written as y minus 1. Substitute this t in the first equation, then apply algebraic method to simplify. Substitute in x equals to t squared minus 2t. Okay, my x is equal to t is y minus 1, y minus 1 squared minus 2 times y minus 1. There you go. Here I have x equals to. I can write it as just y minus 1, then y minus 1 minus 2. A factor of y minus 1, you could just write in expanded form. So my x is equal to y minus 1 times y minus 3. There you go. So x is y squared minus 4y plus 3. This is the equation that you get by eliminating variable t. These two equations are equivalent to each other. Then we can use Desmos, we can use GeoGebra to graph this line. What if I want to use this parametric equation set directly? Well, to do that, I have to form a table, t, different variables for t, x, and y1. Let us start. Suppose t is equal to 0. Let's see here for you. Then your x is 0, your y is equal to 1. The first point on the graph of the function is 0 and 1. X-axis, y-axis, 0 and 1. This is this one here. Let us plug in 1 for t. You get 1 squared minus 2 times 1, which is negative 1. This is your x, and your y is equal to 2. Second point on the graph of the function, minus 1 and 2. Let us plug in, for example, 2. 2 squared minus 4 is 0. 2 plus 1 is 3. 0 and 3. 0 and 3. You can continue plugging different numbers for your t and calculate the position of your particle in xy plane. It seems like the behavior of the function is like this. You can check graphing guess using Desmos or GeoGebra or your graphing calculator. You get the exact same graph. Another example for you. We are on page 4. Example. There you go. This example says, hey, now you have x equals to sine 2 times c. and y is equal to cosine 2 times t, and now your t ranges between 0 to 2 pi. Very well. First of all, we already know that x squared plus y squared. We know that here you have sine, you have cosine. So you can raise both of these to the second power. Sine squared 2t plus cosine squared 2t. And rewrite these so you know that it's y and this is x. Power squared. So x squared and y squared. Perfect. Is equal to always 1. So x squared plus y squared is equal to 1. This is equation of a unit circle. So this is unit circle. What's the meaning of that? It means that we have a circle centered at the origin. It's centered at the origin, and radius equals to 1. Well, I expect you to ask, hey, Professor, in previous example, you said that this is a unit circle. X equals to sine t, y equals to cosine t, t was between 0 to 2 pi, and you said this is a unit circle, and you graphed it like this. You said, okay, I only have one rotation. Counterclockwise. What about this unit circle? This is again a unit circle, but the behavior is it's going to be rotating around x-axis twice, 2 times. So if you want to graph this, the behavior of your particle is like this. X-axis, y-axis, starting from the origin, rotating once. It doesn't stop here. Rotating second time, then it stops. 2 times t, and t between 0 to 2 pi. Since t is between 0 to 2 pi, it means that 2 times t is between 0 and 4 pi. We get 2 rotations around x-axis.